Hey guys, hope you're having a good weekend so far. So this is going to be another 15-minute, hopefully less, screencast on solving equations with brackets. So the learning goal for this screencast is solving equations with brackets. Pretty straightforward. We're just adding on to what we already know and what we learned this week. And make sure that when you're writing your notes down, you write down things. You might solve it in a different way, but make sure form-wise you're following what I'm doing because that's how you'll be marked for your test. Okay, so just make sure you understand and can follow my process. And again, bring your questions with you on Monday. As you've seen, we've got lots of time for you to ask them, and most of you have really been taking advantage of that time to ask questions, so I'm happy about that. But yeah, okay, so let's get started. So pretty much when we're solving an equation with brackets, the first thing we're going to do is expand by using distributive property. So that's pretty much the only thing that's different. Because then we're going to collect like terms and we're going to isolate for the variable, which means get it by itself. Oops. So we have already been doing that. It's just the expanding part that's a little different. And so we're just adding a step to do at the beginning, and then we can collect like terms the same way we've been doing it. Okay. So, oops. Okay. All right, so in the first example, let's try it out. So this looks like things we've seen before. You can do this. You've done this on tests. So what we're going to do is we're going to use distributive property, and we're going to multiply this 2 times that x, and then this 2 times that negative 1. It gets applied to both things. So in our answer, we're going to write 2x minus 2 equals 10. And then we just have to collect like terms. So same as before. This isn't changing. So these are from the last lessons. This looks like something from the last lesson. And so now all we have to do is collect like terms. So this negative 2 is going to be brought over to the other side, and it becomes positive. And then we just add these numbers. So we get 2x is equal to 12. We're going to divide both sides by 2, and we get x is equal to 6. Okay, so we just added that step in at the beginning. In the next example, we're going to do the same thing. So we're going to expand this part out first. We're going to get 3n minus 12 minus 9n equals negative 6. So notice that these got expanded, these got multiplied, but the negative 9n didn't have, the 3 didn't have an effect on the negative 9n, and obviously not the negative 6, so I just rewrote that the same way, same signs for now. So now we're going to collect like terms. So we have this 3n and this negative 9n that we have to put together. And then we have this negative 12 and negative 6. Okay, and we want to bring all the variables to one side and all the numbers to the other side. So if we keep the variables on one side, we're going to have 3n minus 9n. So notice that the signs didn't change, right? Because I haven't moved anything over the equal sign. Okay, so not moving over. On the other hand, to get the negative 12 and negative 6 on the same side, we have to move it. So negative 12 moves over here and becomes positive 12. Now we can see that we can add these numbers, and the only thing that's changed is this sign here. All right, so we're going to have 3 minus 9 is negative 6n is equal to positive 6. We're going to divide both sides by negative 6 to get rid of there, and we're going to end up with n is equal to negative 1. I'm going to go through this example a little bit quicker, so if you need to, pause or go back. All right, so we're going to expand here. We're going to get 3x minus 12 is equal to 9x minus 3. All right, so that's the first part where we use the distributive property. Then we're going to bring this 3x and this 9x over to the same side. So we're making this negative. We have a negative 3 that's staying and a positive 12 that's coming over. We get negative 6x is equal to positive 9. Divide both sides by negative 6. Cross that out. And now we have x is equal to negative 9 over 6, which is the same thing as negative 3 over 2. Now notice that I flipped this negative. I went from the bottom to the top. It means the exact same thing, so don't forget that. But form-wise, so like on your test, you would write the negative at the top for your final answer. It just makes things a little bit cleaner, but it does mean the same thing to have that at the bottom and the top. I also just want to take a minute to show you, in relation to our very first lesson in this unit, what we're really doing here. So in terms of balancing the equation and making sure that our operations are the same to rearrange things, if I rewrite this again, this first line, I'm going to get 3x minus 12 is equal to 9x minus 3. So let's look at this 9x first here. Now, we want to move that over, but what that's really doing is we're trying to get it to the other side. So in order to get rid of it on this side, I'm just going to write out a little bit of space. We need to subtract it on this side, okay? And if we subtract it on that side, we have to do the same on the other side. And what that's doing is it's creating a situation where we have 9x minus 9x, which is just 0. And so we have it on the other side now, okay? Same thing with the negative 12 here. If we want all the numbers on the other side, we need to add 12 to this side to get rid of that, and that means we have to add 12 to the other side. So we're crossing these out because negative 12 plus 12 is 0. And that way we can end up with the variables on the same side. So that's the same way we did it before. Okay. Now, I'm just showing you that because it takes a lot longer to do that, but sometimes we forget why the sign is changing. And it's not just that it's magically changing, it's that we're using these balanced operations. So I want you to understand that. Even though we might not write these steps out because we can do it faster now, we have a little bit of a shortcut, that's actually what's happening. All right, so in the next example, we're going to do the distributive property first again. So the 4 gets applied here, and the 3 gets applied to both these. So we're going to end up with 4m, 4 times m. 4 times negative 3 is negative 12, okay? So you just have to do that and write it down. You don't need to do like the plus, let me just pause it for a second. So you don't need to write plus negative 12. If you need to, that's fine, but if you think of it as you're just going along, as long as you have a sign separating everything you're doing, you're fine. So you're saying 4m, and then all you got to do is say completely separate from the question, what's 4 times negative 3? And the fact that you're getting negative 12 tells you that you can put it like that, okay? Then we've got this plus 3m happening, and then plus 6 is equal to 8. Okay, then we're going to collect like terms, so I like to do my variables on this side, 4m plus 3m, and then we're going to keep the 8, and we're going to change the sign on the 6 and the 12 because they're coming over. We're going to get a 7m equals 2 plus 12 is 14. Divide both sides by 7 to get the m by itself, and now we've got m is equal to 2. Okay? Alright, I want you to try this example by yourself, and then you can check the answer. I'll just let this one play. So pause now. Okay, and here's the answer. Again, I really do recommend you pause and try the questions because that'll tell you if you need to go back to the beginning of the lesson, which is perfectly fine, or if you need to, if you're good. I'm just going to show you here how this is really what we're doing. We're doing the 4 times 2x, 4 times negative 1, 3 times 2x, and 3 times 2. So notice that I wrote negative 4 times 1, even though this one was negative, because regardless, you're going to end up with a negative number. So start getting in the hang of that, and if you're confused by that, please do talk to me because I'd like to explain it to you. That way you're good, because it's something that'll help you a lot when you're doing your algebra. So we can collect like terms. It's just showing you what that equals, which is the same as this one. We'll collect like terms. And we'll end up with a 2x over here is equal to 10. Divide both sides by 2, and we get x is equal to 5. I'm going to color code this example. Maybe that will help some of you see it. So this 6 times negative 2 is going to give us a negative 12. Then we're going to do 6 times negative n, which is negative 6n. Then we've got negative 5 times 2n, which is negative 10n. And finally, we have negative 5 times 4, which is negative 20. We'll collect like terms. So we have the negative 6n. We're moving this over right? So on the other side, we are keeping this negative 20, and now we're moving the 12 over. We're going to collect, we're going to simplify like terms, so 4n is equal to negative 8, divide both sides by 4, and we get n is equal to negative 2. Just to change it up a bit, I'm going to show you the answer to this question and explain it. So we expanded this part, we got 6 minus 12x plus 4 stays the same is equal to 5 times 2x, and then you do 5 times 2 and get 10. Alright, so after that, we collect like terms, so I kept the negative 12x over here, and I brought this 10x over, which made it negative. I left the 10 over here, and I brought the 4 and the 6 over, so they both became negative. Then we add these two, which negative 12 minus another 10 is negative 22x. 10 minus 4 is 6, minus 6 is 6. So remember, anytime we do 0 divided by a number, we get x is equal to 0. So it doesn't matter what this number is, you can still show that you're dividing it, but any 0 divided by any number is equal to 0. For our last example, we're going to expand again. So we have 6m plus 3. Now this negative, okay, we're going to expand it the same way. So negative, it's like a negative 1 times m is negative m. And then we've got this plus 2 because negative 1 times negative 2 is plus 2. Okay. Now I want you to remember though that what we're doing, remember when we learned the subtraction rule? Okay, that's what this is. So we're flipping, we're also just flipping the signs. So you could look at this as that or distributive property. That's what I mean by DP there. So we learned in, I think, the second lesson, or a lesson for the last test, that when you subtract a polynomial, you just flip the sign. So this positive m would become negative, and this negative 2 would become positive. So you can look at it that way, or you can look at it as a negative 1, and you're distributing it and multiplying it to everything in the bracket. It works either way. It's the same rule, essentially. We just kind of divided it up because that negative, a lot of people don't associate with the number, even though it's a negative 1 technically. So that's fine either way as long as you get that at the end. And then on the other side we've got this 2m plus 8. Just multiplying it using distributive property. Okay, and then we'll simplify. So we're going to collect all these like terms on one side because we had the 6m, the negative m, and the 2. So only the 2 changed signs because we brought it to the left side of the equal sign. On the other side, I always start with this 8. Like I write whatever was already on the side, and then I add in the things that we're bringing over. So a negative 3 now and a negative 2. All right, and then we're going to get on the left m minus 2. So that's like 6 minus 1 minus 2 is 3m. And then 8 minus 3 is 5, minus another 2 is 3. So we get 3 there. Divide both sides. We get m is equal to 3 divided by 3, which is just 1. And that's it. So make sure your note sheet's complete, come with questions. We're going to do homework in class, sign and correct tests, same old. So if you didn't correct your test yet, solutions will likely be posted by the end of the weekend. So please make sure you do that. And the other thing I really suggest you do is go back to the other videos if you need to and review. There's not a ton to do this weekend. This is a 14-minute video. But really make sure you're pausing if you need to, because I want to know that you get it. And if you don't get it and you're not coming with questions, that's a problem. So go back if you need to, rewatch and review what we've done so far so that when we add something else on Monday, or Monday night, you're capable of doing that, because we're just going to keep adding and adding on with different concepts. Okay? All right, see you later guys. See you Monday.